all. Thank you for the invitation. Do you hear me well? Excellent. I'm the chief data scientist of Intel's internal AI solutions group, and I'm going to give you an overview of how we apply AI in general and specifically also generative AI internally inside Intel. I'll start with a little overview. Let's see what happens. I'll start with a little overview about AI at Intel, some background. AI has three different roles at Intel. The first one is that Intel is providing hardware and software for AI. You probably heard about Habana, the Israeli company that Intel acquired a few years ago and offers the Gaudi accelerator for deep learning, recently published also a benchmark for large language models. And this is a part of several hardware and software offerings that Intel develops or is working on. This is not going to be the focus of my talk. This is not what my group is doing. The second part is using AI for making our products smarter. So you probably all heard about Mobileye that Intel acquired that makes cars smarter. But we also use AI to make our processors smarter. And I'll touch on that later. And the third part is using AI to transform our own operations. There are vast amounts of data generated in our design and manufacturing processes, tables, time series, text, images, videos. And we use this data to transform and upgrade our internal processes, making them much more efficient using AI. And this is the focus of my group. So my group, the Intel AI Solutions Group, is a group whose main mission is to transform and upgrade Intel's critical work using AI. We exist for over 12 years. We have over 250 AI professionals, almost all of them in Israel, in Petah Tikva, Haifa, Kiryat Gat, Beersheba, and Jerusalem. And we already have over 500 solutions in productions to date. You can see below the 5 main verticals in which we are active. There are some additional ones that are kind of newer startups. So the first one is what I mentioned about making processors smarter or making them adapt to their usage. When you buy a laptop or desktop, you sometimes use it for browsing the web. You sometimes using it for watching movies. Sometimes you run a model on it. There are different usages. So we put AI models inside the processors that help them understand the current usage, predict the usage that is going to be in the near term, and based on that, make decisions that make the processor more efficient, providing higher performance and consuming less power. So whenever you buy a laptop or a desktop with Intel inside, you have AI inside the processor, the models we develop. Another vertical in which we are active is design and validation. So you probably saw some sci-fi movies or read some sci-fi books in which robots develop the next generation of robots. Sometimes it's considered a utopia, sometimes it's considered a dystopia. We hope that it's going to be on the positive side. So we use AI to, it doesn't do the whole design yet, but we use AI to accelerate the design processes of the next computers based on historical information that we have about previous designs, about previous problems or bugs in designs. So AI is used for both for the design and for validating the design and detecting problems or bugs in it. Another type of verticals in which we are active is manufacturing and product engineering. And here again, the story is personalization. Instead of producing all the processors just the same way, we personalize the manufacturing of each processor based on what happened to it until that stage of the manufacturing. So we have lots of information about what happened to that specific unit when it reaches a specific machine, and then we can personalize what is done to it, how it's tuned, based on what happened earlier. And it's not just at the processor level, also at the factory level. We can personalize how the factory treats a specific machine based on what happened to that machine. And last but not least, we don't just help machines, we also help people, our salespeople. So we have AI applications that help them understand which companies to contact, what to offer them, based on crunching a lot of data, and I'll elaborate a little more about that later. All in all, our solutions are estimated, the estimated value of our solutions to Intel, according to the finance calculations, is over $1.5 billion per year, accumulated over all the models that do the cost savings and the increased sales. So the topic of today is AI and generative AI. And I listed here the three key applications, I think, of generative AI that emerged in the recent years. Language models that know natural language, machine programming, which is just language models that know how to program, and image generators that were also mentioned here before. And of course, these innovations have a significant impact on what we do. So starting with language models for natural language, so the first thing is that many of the NLP-related tasks that we had before, like classifying websites of companies or analyzing various social media information, things like that, are now done much easier, much faster, and in a much more accurate way using language models. It started with BERT several years ago, but now with GPT-4, it's of course much more efficient, and also we're also fine-tuning internally our own language models with our own vocabulary. So one thing is making applications easier and faster, but another aspect is that we are able to offer our internal customers new types of applications based on language models. And of course, the first thing that people wanted is having their own ChatGPT. So we developed our internal question answering agent, which uses our internal confidential data and answers questions to help people get the information, consolidate the information, and so on. Usually information is scattered over many file types, and just consolidating it has value, but the fact that it summarizes it rather than providing links is, of course, very valuable. On the machine programming side, there are many tools that exist externally, and our focus is on languages that are not popular languages that are handled by external tools, but rather proprietary programming languages that are important to Intel internally. And there, of course, machine programming can do various different things. Our first focuses were on debugging and summarization of programs rather than generating code. But code generation is also of interest to some of our users, and it has some IP-related issues. It depends on what data you use for it, but it's also interesting. And regarding image generators, we haven't found ways to use them internally yet, but they already create problems for us, for the company. In some interactions that Intel has, some sort of interactions, fake images or generated images create issues, and it is important for Intel to be able to identify fake images or generated images in various contexts. So this is ongoing work that we do, some of it in collaboration with Academy, on being able to identify those fake images. It becomes increasingly challenging. So this is still work in progress. I would like to talk a little more about, before moving to a use case, I would like to just say that there's a lot of attention to these models. Attention is all you need. But of course, in the recent years, there was significant progress in other areas as well. Some of these areas are the techniques behind those applications that I mentioned in the previous slide, but some of them are not related, like graph neural networks or deep learning for tabular data. And so I listed here just some list of AI techniques that made a significant way forward in the recent years. And most of these methods are methods that we used in some of our projects, at least experimented with. So it's important to remember that there are additional developments in AI other than just the generative AI main developments that we are all aware of. As a reviewer in NeurIPS, I see many types of papers on many areas, so it's not the only thing that moved forward. I would like to talk a little about one of our use cases, which is AI solutions for sales. So Intel sales are B2B. We sell to companies that integrate our processors inside computers or machines. And usually those companies register to our partners program, so we have a lot of information about them, about the company profile, we have the sales data, we can get, we have their websites, we can get the social media information, we have news articles about them. And we have an engine that crunches all this information and provides two types of outputs. One of them is sales assists, telling the salespeople that this company now started a new product line or was acquired or launched something new or had some investment and it's a good time to contact it. And another type of output is recommendations based on deep recommendation systems. Some of it is handled by salespeople, some of it is handled by bots. And all of this NLP work that was handcrafted in the past is now being replaced by large language models that do all this analysis of social media and websites and so on. It's interesting to see how even the sophisticated language of tweets is now being processed very well by those language models. I won't have time to go into the details, but we did have some publications about this line of work, starting with collaboration that we had with the Stanford AI Lab, some additional papers, and also a podcast in Hebrew about what we do there. So if you're interested, you can look at it. I mentioned that we have many verticals, and I won't have time to describe all of them. Most of our work is confidential, so we don't publish about it, but you can also see some papers about our line of work related to visual anomaly detection. We had some papers in the NeurIPS workshops and also in the recent KDD conference. I mentioned that we also look at tabular data and how various deep learning methods can be applied to it. So we also had recently a high-profile paper about that had over 400 citations just in 1 year, checking how tabular data can leverage deep learning methods. Still, trees are better, but in some cases, deep learning may work well, and there was a lot of discussion in the industry following this paper. And last but not least, I said that we use AI to increase hardware performance. So that's a secret sauce that we cannot say a lot about, but still we did say some things about it. So if you're interested in more details, you can see them in this talk of my colleague Avishai. If you have additional questions, you're interested in what we do, you can contact me directly or listen to our AI podcast under Osim Historia. It's in Hebrew. And I should also say that we have open positions, part-time positions for students, especially graduate students in the field of AI. So if you're interested, you're welcome to send me your CVs. So thank you.